Hi everyone, today I am going to start geometrical optics. In that first we are going to see refraction at plane surface. Then after that curved surface. Similarly reflection at plane surface and curved surface. These are the four main topics in this geometrical optics, ray optics. Now see refraction at plane surface. See, here is the plane surface of separation between the two mediums of refractive index mu1 and mu2. See here, a light ray, a beam of light rays, parallel beam of light rays, incidence at an angle I, since the medium changes, it deviates from its path. So this is the light ray, travels from the medium of refractive index mu1. Mu1 is a refractive index here and mu2 is a refractive index in the second medium. So velocity of light here is v1, wavelength lambda 1. Here v2, lambda 2. And we are going to get R refracting angle here. We are going to get the relation among these terms here. So first one is, as we know, definition of refractive index says mu1 equal to refractive index is velocity of light in vacuum by velocity of light in this medium v1. So mu1 equal to c by v1 and mu2 equal to c by v2. So this is the definition of refractive index. Refractive index is nothing but the ratio of velocity of light in vacuum to the velocity of light in the medium, that is v1. Mu2 is c by v2. So therefore eliminating c here, I will get the first equation mu1 into v1 equal to mu2 into v2. So this is my first relation. And we know that velocity is equal to f lambda. Means if I substitute here, means v equal to f lambda, mu1 into f lambda 1. Frequency remains same whenever the light ray travels from one medium to another medium. So which is equal to mu2 into f lambda 2. Wavelength, the frequency gets cancelled, means I can say mu1 into lambda 1 equal to mu2 into lambda 2. Second equation, right? Now I am going to the third part. Here you see, you drop a normal here. So here is the normal and here this is the normal. I am going to name this as AB, A dash or A1, B1. AB is like a normal drawn to the two parallel light rays. So this is normal here. And you see here T0 and this is the time T. So in the time T, the first light ray is in the second medium. Second light ray, see this is, I am taking second light ray, this is first light ray. Second ray is in the first medium. It travels with the speed v1 and it travels with the speed v2. Because of the difference in velocities, refraction takes place. Because of difference in velocities, refraction takes place. You see here, I can write, distance equal velocity into time, velocity into speed into time, means I can say here, the distance traveled from here to A1 equal to velocity in this medium is v2 and time of journey from here to here is t. Means I can say A1 equal to v1 into t. And at the same time B1 is, this is v2 into t because the light ray is in the second medium. B1 is the distance traveled by the light ray is this much in the time t with the speed is v1. Means I can say B B1 is V2 into T. So, as their velocities are different, they travel different distances in the medium. So, therefore, I am going to see here sin I, you see sin I equal to, so here is I, so complementary angle 90 minus I, and here is I. Similar way, here R, complementary of 90 minus R, and here R. So sin I is nothing but opposite by hypotenuse. Means sin I is nothing but B1, nothing but V2 into T by hypotenuse is AB1. Comma. Now you see sin R. You see sin R equal to opposite by hypotenuse. Opposite side by hypotenuse. See, this is right angle. So opposite side is V2 into T. See, this is V1 into T by AB1. Clear? This is sin I equal to opposite side by hypotenuse is AB1. Opposite side is V1T. Sin R equal to V2T. Opposite side by hypotenuse is AB1. So eliminating AB1 here, AB1 here, T gets cancel, means I will get here, you see, sin I by sin R equal to, sin I by sin R equal to V1 by V2. Nothing but you see V1 by V2 equal to mu2 by mu1. You can say it is mu2 by mu1. So here you can see therefore I can say mu1 into sin I equal to mu2 into sin R. You see here, this is what Snell's law. See, if V1 equal to V2, I equal to R. So, higher the angle of incidence, higher the angle made by the light ray in the medium, refractive index will be like, depending on the refractive index, the angle varies. Higher the refractive index, lesser the angle. Lower the refractive index, higher will be the angle made by the light ray with normal. So that's what, light ray bends towards the normal, away the normal. If mu1 is, mu2 is higher, R will be lesser. And mu2 is lower, R will be higher. So like this. So these three are my base formulas. And one more thing here, about the diameter of the beam. Diameter means here I am going to take this beam light ray, the difference between these two rays is equal to A. Before, like in the first medium, and here the diameter of this beam is, say, B in the medium of refractive index, second refractive index mu2. Same as usual. Let us take cos I. Cos I equal to A by AB dash. Cos I equal to adjacent side. Adjacent side is the distance between these two rays, nothing but the diameter of the beam. Suppose the beam is coming like this, the diameter of the beam indicates the distance between these two, nothing but A upon AB1. Similarly, you take cos R, adjacent side by hypotenuse. Adjacent side is B. Cos R is, adjacent side is B upon AB1. Means I can write the diameter A by cos I in the first medium, B by cos R in the second medium. So this is one important relation. The questions are coming in this, like the questions will be given in this way. A light ray incidence at an angle 30 degrees, I value 30. Light ray incidence at an angle 30 degrees in the medium of refractive index mu equal to 1. Find the refracting angle if the refractive index is 3/2, glass medium. We can find out I value, R value. A is the diameter of the beam here, B is the diameter. We can get the relation here. So let us see the problems related to this topic. We'll see in the next video, right?